Hello again, it's Mrs. Hoekstra. We're working on Module 2, Lesson 13. I'm on page 77. Lesson 13 is converting between fractions and decimals using equivalent fractions. All right, your favorite and mine, fractions. All right, essential question. How can any terminating decimal be converted to a fraction? All right, we're going to be looking at fractions that terminate and vice versa. Terminate means they end. Okay, it's not a repeat. Doesn't do any of those crazy things. We're just talking about simple, straightforward fractions here. All right, so example 1, representations of rational numbers in the real world. So basically, I want you guys to stop and think. When do we use fractions in the real world? And when do we use decimals, right? Because sometimes decimals are better in some places, as much as that bothers me. And sometimes fractions are better, which is, of course, awesome. Okay, well, I don't know how much cooking you all do at your house or how much you help your parents around the house with cooking, but cooking always uses fractions, right? You'll talk about 1/3 of a cup or a 1/2 a teaspoon. So fractions are used primarily in cooking, at least in the everyday world. So fractions are used in cooking, right? Even in sports, right? You have the first quarter, second quarter, halftime, those types of things. They're using fractions. And then in decimals, the most famous and most loved decimals of the world is basically money, right? Money, it would be very weird to talk about money and I need 1/3 of a dollar, right? You wouldn't say that. You're going to talk about how much it is in decimals. Money uses decimals, right? So those are just two. There's lots of different examples of where you use that. All right, and sometimes you use one only, like in cooking, and sometimes you use fractions and decimals, depending on the circumstance. Okay, distance, you might talk about 1/10 of a mile. 1/10 of a mile could either be the fraction, or it could literally be 0.1 of a mile. You could write it either way. Both are going to be acceptable. All right, so example 2, using place values to write terminating decimals as equivalent fractions. I know lots of students struggle with knowing maybe their place value. You might know your tenths and your hundredths, but when it gets much past that, it starts to become a struggle. So I'm going to show you my shortcut. I had a student show this to me years and years and years ago, and I went, oh, that's an awesome way, and so now I teach it. So it says, what is the value of the number 2.25? How can this number be written as a fraction or a mixed number? Well, obviously the 2 is a whole number, so we're not going to deal with that, but I want to talk about the 0.25. All right, so I want to show you how to use place value to help you write this. So what you're going to do, those of you who struggle with figuring out those place values, you're going to put basically kind of like an invisible 1. I'm going to put it like a little dotted line 1 underneath the decimal point, not under the 1, or excuse me, not under the 2, but under the decimal point. And then I'm going to put zeros in every place behind the decimal point. Check that out. All right, so now I actually see what place value the 5 is in, right? I see the place value that the 2 is in. That 0.2, look at it. It makes the number 10 right below it. The 0.25, what number does it have? It has 100, so 0.25 hundredths, right? You could say this as 2 and 25 hundredths. Okay, 2 and 25 hundredths. Now, all of a sudden, you're like, oh, I know the place value. All right, so the 2 stays out front. No big deal there. And then you're literally going to write the 25 over that number that you just made by putting that 1 with the zeros behind it. Okay, so that is technically right. That is what you are literally going to say. 2 and 25 hundredths. However, I also do know that I can reduce that. Right, I do know what goes into both of those. So I'm going to actually reduce them. It doesn't say to do it, but actually it says to do it in the next problem. So let's just rewrite it down here. 2 and 25 hundredths. Ask yourself, what goes into both 25 and 100? Should be, hopefully, evident to you. I can divide both the top and the bottom, because what you do to the one part of the numerator, you have to do to the other part of the numerator. And I'm going to divide both of them by 25. Because 25 goes into both, right? So the 2 stays out front, no big deal, nothing's changed. And then I just do 25 divided by 25, which is 1. And 100 divided by 25, think of it as a dollar, right? I have a dollar and I want to split it into 25 cents. How many of 25 cents goes into it? 4, 1/4. There we go. So it says, rewrite the fraction in its simplest form, showing all the steps that we use. We already did that. How do we do that? We have to look for a common factor, right? That's what we did. I actually put this in the wrong spot. We have to look for a common factor. And in this case, our common factor in both the numerator and the denominator was 25. Look for a common factor in numerator. That's the top one. And denominator. Denominator is the bottom one. Here's how I remember that. Denominator is the number on the bottom. Haha, catch that? All right, let's take a look at this next one. What is the value of the number 2.025? Notice we've got an extra digit in there from a minute ago. How can this be written as a mixed number? All right, so let's take this and we'll put the 2 out front, 0.025. Now go back to what I did a minute ago. I'm going to put an invisible 1 at the decimal point and fill in a 0 under every place value, okay? Again, some of you, this makes total sense. You can already tell what place value that 5 was in. Others of us, we struggle with that, and that's okay. This is hopefully going to be a good way for you guys to see how this works. All right, so now that I've got that, I'm going to change this. The 2 stays out front. Don't do anything to it. What would be my numerator? My numerator is going to be 25, isn't it? And then over, and then I write out all those digits. 1, 2, 3 zeros behind it. So 2 and 25 hundredths, or excuse me, thousandths. You would read this as 2 and 25 thousandths. Because I know sometimes we struggle with even knowing just how to read that. Okay, so if we say it with that place value, it makes it even easier to figure out what place value goes into as well. All right, rewrite it, right? It says to rewrite this. So I'm going to take that 2 and 25 thousandths, and I've got to find a common factor. What does both the numerator and the denominator have in common? Well, a little while ago it was 25, and it still is, right? I can divide 25 into both the top and the bottom. So the 2, the whole number doesn't change, but I can reduce that fraction. 25 goes into 25 one time. Now a minute ago, 25 went into 100 4 times. Well, I just have an extra 0. So it's going to go into there 40 times. See how that worked? Right? Just take what we knew from a minute ago, right? Take this knowledge here, that gave me a 4, and turn it into 40 because I've got this extra 0 here, right? It's called number sense, understanding how those numbers all work together. Hopefully that made some sense to you guys. Some of you were able to figure this out. In fact, if you go to the top of the next page, page 78, exercise 1, I want you guys to pause, see if you can figure these 4 problems out using the method I just gave you, okay? You try this on your own and go ahead and hit play when you're ready. Okay, so take a look at my answers here. For A, I ended up with 109 over 500. Okay, I ended up with 109 over 500. I had 218 over 1,000, but I know that they're both even numbers, so I divided them both by 2, and that's how I got that. So if you didn't reduce it, go back, pause, and hit, get that on there. For B, I ended up with 4 over 25 because I knew both the numerator and the denominator were multiples of 4. Okay, so again, if you didn't reduce it, hit pause and do that division so you reduce those. For C, I have 2 and 18 25ths. So the first time I did this, I had 72 over 100, and I divided both by 2 because I knew they were multiples of 2. And so I had 2 and 36 50ths. So if you had that, great, you reduced it, but they're both even still, so you have to reduce it one more time. So again, if you need to, hit pause and get it so that you reduced it all the way down. And then for letter D, I have 5 over 10,000, but both of those are divisible by 5. They're both multiples of 5, so I divided them both by 5. And I know some of you are going, oh, I can't do this without my calculator. Sure you can. You can take 10 and divide by 5, and you know the answer is 2, and then toss in all the zeros. Okay, so you can do this without a calculator. It's not impossible. All right, let's take a look at example 3 now. Example 3. What are decimals? Decimals are those points between whole number points, right? And then deci literally means 10, okay? It literally, that prefix deci, like, right? That literally means 10. So we're talking about powers of 10. Okay, so now let's go and we're going to work the opposite direction. But this time we're going to look at it slightly differently. All right, we've got the number 3 over 100 as a decimal. And it says, you know, rewrite this, right? So 3 over 100. Or I could read it, right? This is 3 hundredths. So I know 0 point, and then you're like, oh, what do I do? You can do like we did a minute ago. Put the invisible 1, add the invisible zeros underneath it, and then just fill in. The 3 has to be in that last spot. The 3 has to be in the hundredths spot. So then I just fill in the zeros where I need to. Okay, and that's how you can do it. You can actually take the concept from a minute ago and actually use it and go backwards with it. Okay, and that works great if it's a power of 10. But take a look at my next one. It's not a power of 10. It's a 20. So we're going to actually do this one a little differently. The key to this is actually to find powers of 2 and 5. Like if you went back to factor trees. Do you guys remember factor trees? Kind of have to use that idea of a prime factorization tree to help us figure this one out. Okay, so what we're going to have is we're going to write 3 over 20. Okay, 3 over 20. And by the way, 20 is really what? 20, I'm going to do a little thought bubble over here. 20 is really 4 times 5, but that's not prime. Prime numbers, that'd be 2 times 2, and then times that 5 still, right? So really 20 is 2 squared, right, because there's 2 2's, times 5, okay? And I want to make this be a power of 10. Right now it's 20. Okay, I also want you to notice that that 2 has a squared, right? There's a little square there. And the 5 has nothing. Technically, it has a 1. We're just super lazy and don't write it in there. Okay, technically, it's got a 1 there. I need both of those powers to be the same. Need exponents to be the same. And they're not right now, are they? So I'm going to multiply both the top and bottom, because remember, what you do to one, you have to do the other. I'm going to multiply both the top and the bottom by 5. Because when I do that, I make this 5 and 5, and I have 2 of them now, right? 5 squared. Okay? Now, when I do this, my numerator becomes 3 times 5, which is 15, and my denominator becomes, which was a minute ago, 20 times 5. 20 times 5 is 100. Now I know some of you are like, well, couldn't I have just multiplied both the top and bottom by 5 a minute ago? Yes, I'm explaining why that works, why it had to be 5 and not 17 million, okay? So now I have 15 over 100. This makes it easy because I can literally say 15 hundredths. Right? I can literally say 15 hundredths, 0 point, and again, I can put my invisible 100 down below and fill in where's the 15. The 5 has to be in the end of the 100, so I'm literally going to write 15 over 100 like that. Okay, and that's how we can work this backwards. All right, take a look at this next one. Now, there's lots of ways to go about solving it, but I want you to understand this particular method because it's probably a method you haven't seen before. All right, 10 over 25. Again, I want to rewrite this, okay? I'm going to change 25. I want to write that as 5 times 5, right? Which is also the same as 5 squared. Okay, so I want to rewrite this as 10 over 5 squared. I need this to be a power of 10. So I'm going to have to multiply everything by 2. Okay, some kind of a multiple of 2 so that I can get 25 all the way up to 100. Now, most of you probably do realize 25 times 4, right? 25 times 4 gets me to 100, right? Well, 4 is actually 2 squared, which makes sense because, hey, look at my 5 is squared, and I need to multiply by 2 to the exact same power. I have to have the same powers. So I'm going to multiply both the top and bottom by 2 squared, also known as 4. All right, so let's come over here. Let's do some magic. 10 times 4 is 40. And 25 times 4 is 100. Okay, and so then I can rewrite this, and I end up getting 0.40. Or you don't have to have that extra 0 on the back. You could have said 0.4. That would have been acceptable as well. Okay, now let's take it up a whole nother level. 8 over 40. Okay, 8 over 40. So many different ways I could start this problem. I think I'm actually going to start by reducing it first. Okay, I'm going to reduce 8 over 40. What goes into both 8 and 40? Both factors of 8, right? So I can divide both of those by 8. So now I have 1 over 5. 5 is raised to what power? It's raised to the first power. And remember, I need to turn this into and multiply by 2 to the exact same power, right? This is to the first power. I need to raise 2 to the first power. So when I multiply both the numerator and denominator by 2, 1 times 2 is 2, and 5 times 2 is 10. All right, how do I write 2/10 as a decimal? 0.2. Right, there's 2/10. If you had done it so that you got all the way to 100, that would have been fine, but you would still get the exact same answer. All right, top of page 79. All right, let's give this a try. I know normally I say, hey, hit pause, but we're not going to today because I think this is still kind of new to you all. If you are feeling confident, go ahead, hit pause. Try these on your own. If you're really shaky on this, you're like, yeah, I'm still struggling, then just stay on with me right now and see if you can get the same thing as me. All right, so here I go. I've got to change 3/16, right? So first thing I'm going to do is I'm going to think about what makes 16. 16 is 4 times 4, right? And 4 times 4, 4 is just 2 times 2. So the prime factorization of 16 is actually 2 to the 1, 2, 3. I have 4 of them here. 2 to the 4th power. My denominator has to have both a 2 and a 5 in it in order for this to work. So I have to multiply both the numerator and denominator by 5 to the what power? They have to have the same power, so I'm going to multiply both the numerator and the denominator both by 5 to the 4th power. I'm going to rewrite that one because that exponent didn't look good. 5 to the 4th power. You're like, oh no, I don't know this. It's okay. Down in the bottom, right? Those are just tens. There are 4 tens. 10 times 10 times 10 times 10. That's really all that is. So 10 times 10 is 100, times 10 is 1,000, times 10 is 10,000. Okay? Now the top one I will definitely help you with. 5 times 5 is 25. And then another 5 times 5 is 25. And 25 times 25 is 625. How do I know that? Because I'm a crazy lady and I have certain crazy facts memorized. 5 to the 4th power is 625. So I'm going to multiply 625 times 3. And you're all going, oh, I don't have a calculator. It's okay. What's 3 times 25? 75. What's 3 times 6? 18. 1,875. Boom. Just like that. All right. Change it to a decimal. 0. No, I don't know. I'm going to put in my 10,000 below because I want to make sure I have this right. 100,000, 10,000. So the 5 has to be in that spot. The 7 has to go above that second to the last 0. The 8 has to go in the second spot, and the 1 has to go there. There we go. There it is. All right, let's try the next one. 7 over 5, right? I need that to be a power of 10. Easiest power of 10 is to literally multiply that by right? If I just multiply both the top and bottom by 2, I can get my power of 10. So this becomes 14 over 10. It's improper. How many times does 10 go into 14? Goes in there once with 4 left over, right? Doesn't say change it to a mixed number. As much as I love those, it says I got to change them to a decimal. All right, 1 and, where's my 4/10 going to go? 1.4. Look, could we have changed it so that was 100 on the bottom? Sure. We would have still gotten the exact same answer. We just would have had a 0 behind the 4. All right, 11 over 32. 11 over 32. Here we go. 32. What makes up 32? 32 is actually 2 times what? 16. And 16 is 2 times 8. And 8 is 2 times 4. And 4 is 2 times 2. 1, 2, 3, 4. There's 5 of them there. So 11 over 2 to the 5th power is really what we have going on here. I need to have this have a multiple of 5 with the exact same power. It's a 5. So I'm going to multiply both the top and bottom by 5 to what power? To the 5th power. All right. Again, you're all panicking. Don't panic. The bottom, that's 5 tens. 10 times 10 times 10 times 10 times 10. Just keep track of how many zeros you need. 1, 2, 3, 4, 5. 100,000. All right, I'll do the top one. All right. 11 times, 5 times 5 is 25, 625. I don't remember that one off the top of my head. I'm just going to look at my notes here. Sorry. I have 3, 4, 3, 7, 5. 34,375. Change that over to a decimal. Okay? 0 point. Now I'm going to put in all the zeros. 2, 3, 4, 5. The 5 has to be in that last spot. 5, 7, 3, 4, 3. Excuse me, 0.34375. All right, 35 over 50. 35 over 50, let's rewrite. What makes 50? 50 is 25 times 2, right? And 25 is really 5 times 5. And 5 times 5 is 5 squared. Okay, so this is really 5 squared times 2 in the denominator. I need them to have the same power, right? They need to have the same exponent. Right now, the 2 does not have a 2, does it? So in order to change that so that they have the same power, I'm going to take 35 over 5 squared times 2 and multiply both by 2. So that I now will have, what, 75 over 5 squared times 2 squared. 10 times 10. That's all that is. Excuse me, not 75, that's 70. My bad. Please forgive me. That's 70. All right, so now I have 70 over 100, which becomes 0.70 or 0.7, either one. All right, when you guys come back to class, I'm going to have you fill in that summary. We've got lots to put in there so we can put it all together. This was a lot, and hopefully you understand it. If not, come in with questions.